Welcome to this third lecture in a series on macroeconomics. I'm Dr. Anthony Liberatore, and I'm going to be taking you through this next series of discussions. In this particular lecture, we're going to look at GDP, its market value, and try to measure it in a couple different ways, and then look at how we measure prices and inflation in the economy. The first thing we're going to look at is a simplified economy and calculate GDP. So in this economy, over 5 years, we're going to produce hammers. We've already looked at the hammer exercise, so we're going to assume that the economy makes only hammers. And if I looked at the production of hammers over the 5 years, you can see that it's gone 10-10, no growth in production, 15-20, and then production fell to 15. So in year 5 we have a recession. A recession is a decline in the real production in the economy. But when we measure GDP, it's the market value of final goods and services produced in the U.S. in a given year. So we're going to take the market value. And here we can see that I have shown you price, 5, 6, 8, 10, and 20. So prices have risen, but in year 1, our market value of GDP is 50. In year 2, then, as prices go up, it's 60. So immediately you can see that when we're measuring GDP, it has two components, the real production and the price. And in this case, the rising price has caused GDP to rise in terms of its market value, but real production has not increased. Well, let's take a look at how that distorts things as we go through here. 120, 200. Now in year 5, prices have increased so much that the market value of GDP has moved from 2 to 300, but the real production in the economy has actually fallen. And so nominal GDP, the market value of GDP, is really not a sufficient measure for us when we're trying to figure out what's happening in the economy. So for this, we need to take the influence of prices out of GDP so we can measure what's really going on. So here in the last column we have what we call real GDP. And in order to do this, we're going to take the $6 price in year 2, I've got it in red, and we're going to use that price for every year. So let's multiply the production in each year by this given constant price of $6 and look at the patterns that it reveals for us. So 10 times 6 would be 60. GDP in year 1 measured in the prices from year 2 is $60. GDP in year 2 in real terms, that is measured in year 2 prices, is $60. So now by holding price constant we can see that our GDP measure, our real GDP measure, is reflecting the underlying real economic activity. Take year 3, 15 hammers times $6, and we have a real GDP, or a GDP in what we call constant dollars, because we're holding the dollars the same, is 90. Now we get a better reflection of economic activity. As we go to year 5, we can see that GDP has fallen from 120 to 90. So by holding prices constant, we'll get a better measure of real economic activity. So in this little exercise, let me remind you that nominal GDP, that's GDP in the current dollars, is measuring the production and prices in that current year, using the current year dollars. But if we go to real GDP, we're going to take 1 year's prices, for in this case years 2, and value production in all years by that constant $6. So we have what we call constant dollar GDP. And if we want to know what's going on, we have to go to real GDP. So let's move forward on that. The prices then, we can measure how they've been changing. So we create a price ratio. The base year, that is the year we're using to hold constant and measure all other things, would be year 2. If we divide year 2 by year 2 price, 6 divided by 6, it's 1 to 1, or the price in year 2 is 100% of itself. If I take the price in year 1 divided by the price in year 2, I can see that it's 0.833. That is, it's 83% of the price in year 2. Well, one way to think about this in a simplified way is that if a hammer, or say an ice cream cone, costs $1 in year 2, that same cone had a market price of 83 cents in year 1. So there's change in the market price. If I look forward now and look at year 3, and I create a ratio of year 3 price to year 2 price, I can see that we have a ratio of 1.33. That is, the prices in year 3 are 133% of the prices in year 2. That is, they've gone up by 33%. I just carry this simple ratio forward. See, prices in year 4 are 166% of the prices in year 2. They've gone up by 66%. And in year 5, they've gone up sufficiently so that they've more than tripled. The prices in year 5 are 3.33 times the prices in year 2. 333% of the price. So prices have increased 233%. 100% for its base year $6, and then 233% increase over that period. So in national income and product accounts, we're going to measure all the prices of the economy in a kind of a basket, and we're going to use this to create price ratios so that we can see how this basket or all the prices in the economy have been changing. And from that we can measure their relative behavior to a base year or to any other year. Well, let's look forward with this and price ratio into this table in an index form. So rather than showing the price ratio itself, we're going to multiply by 100. So it's in percentage form, or in this case will be an index form. And when we look at the national income and product accounts, and we're going to look at the price indexes, they're going to be in this price index form, not in the price ratio form. But we can see basically how they were calculated in a very simple way. So I have for the 5 years here constant dollar GDP, that is GDP measured in year 2 prices, and it's reflecting real production as we just saw. And in the right hand column I have nominal GDP, that is GDP in current dollars, that is the dollars in each of the given years. And we can see now that the connection between real GDP and nominal GDP is through the price behavior in the economy, or the price index. The price index shows us how prices have changed. GDP, real GDP, measures GDP or the production in any year in year 2 prices, or constant dollars. That's the base year price of, in our last slide, of $6. And nominal GDP measures GDP in its own year price, or in current dollars. We've looked at the notion of GDP in real and nominal terms and price indexes, so now let's calculate some of those things. So here with our simple table, I'm going to take one element out, that is nominal GDP. Now nominal GDP is something that's measured in its current year prices, and without looking at any formulas, etc., right now we can see that real GDP is in 90 because that's measured in year 2 prices. But real GDP in year 3 can be adjusted by the increase in prices to get us nominal GDP in year 3. So let's look at that. The relationship is that real GDP times the price ratio is equal to nominal GDP, and this is just the one equation that you need to recognize and know. Just plug the numbers in here. Real GDP of 90 times 1.33. In other words, we're going to take the prices that existed in year 2, which is 100% of themselves, and the 33% increase in prices between year 2 and year 3, and adjust real GDP upwards by these 33% to get nominal GDP of 120. So it's as simple as that. Real GDP times the price ratio is equal to nominal GDP. In other words, we've inflated GDP by the increase in the price index. So it's easy to calculate that. Now suppose we wanted to calculate real GDP in year 4. Well, I can take the equation and divide both sides by the price ratio to isolate real GDP. I plug the numbers into that. I can see that real GDP is the nominal GDP divided by the price ratio of 1.66. In other words, we're going to take out the increase in prices, the 66% in increase in price from the base year, and we get real GDP in year 4 of 120. Pretty straightforward, right? Okay. The third thing here we're going to do is look at the price index, and again, we can take our basic equation and divide both sides by the price real GDP, excuse me. And this will allow us to calculate the price ratio. So here we can see 300 divided by 90 is 3.33. In other words, the nominal GDP divided by the real GDP is going to give us the difference in prices, or 3.33. So it's pretty straightforward to calculate these things with knowing this one equation. Our first equation, real GDP times the price ratio, is equal to nominal GDP. One other thing, let's calculate the nominal GDP in year 1, just so we can do this prior to the base year. Real GDP times the price ratio gives us nominal GDP, right? So real GDP times the price ratio gives us nominal GDP. But in this case, you'll see that prices weren't increasing, they were less. And so if we get to the nominal GDP, we have to use the prices in that year, and they were below the prices in year 2. And so now the nominal GDP here is 50. Alright, so we've gone through these basic calculations. Let's take what we've done and do this set of historical data. In this table, when you're just looking at it, we've got the same basic information: real GDP, a price index, and nominal GDP. Here in the center, we have what's called the implicit price deflator, or the amalgam of all the prices in the economy, not just one or a set of them, or a subset of them. And these figures come from the national income and product accounts that are reported here by the Bureau of Economic Analysis. You can see their website, and you can go there, www.bea.gov. And in the national income and product accounts are all the components of GDP and their calculations over time. The numbers are in millions of dollars. We'd add a lot of zeros, and just take some of those out. So I've left 3 pieces out, but in red, of course, I'm showing you the recession years. So a recession in year 74, 75, 80, and 82. Of course, if we look across to nominal GDP, we can see that it's continuously increasing. In other words, nominal GDP is not picking up the recessions because of the increase in prices. But let's get the calculation straight. Let's go back and do one of these. Our basic equation, real GDP times the price ratio, gives us nominal GDP. Alright, so real GDP of 5128 times the price ratio of 0.2501. In other words, prices in year 1972 are only 25% of the prices in year 2009, which is our base year. So we're going to reduce the prices that are placed in the GDP numbers to get our nominal GDP of 1282. Great. So we can calculate real GDP. Now we can go on with that real GDP here, dividing both sides of the equation by the price ratio and plugging those numbers in. We can see that we have 1877 divided by 3312, and this gives us a real GDP of 5667. Similarly, for the price deflator here, the price index, take the equation, divide both sides by real GDP to isolate the price ratio, plug in the numbers, and we get a price ratio of 0.4442, or in index form 44.12. So now we've gone from our little example to the actual numbers. We understand the movements between these, and that real GDP is in some base year prices, here being 2009, and nominal GDP is always in its own year price. Now let's look at this table with regard to the price index. And again, we use the price index, remember, to measure the change in it as a measure of inflation. So I'd just like to calculate that for you. We have an index here in 72 and 73, moving from 25 to 26. That's a 5.44% increase. And just to cover our math of it, and if we take the change in the index from 73 from 72 to 73 and divide that by the base amount of 2501, we get 0.054 or 5.44% increase. As typically, this is the change divided by the base. Done it again here in 78 and 79, and it's in red. And I want to do it here because I'd like to do it in one step instead of two. If I divide 79 by 78, that is 40.75 by 37.64, I see that the 78 price goes into the 79 price once for itself, and then 0.0825 for the difference. In other words, prices have increased by 8.25%, and I normally will go to this ratio form instead of doing the change over the base because it's a little quicker. But you should do whatever makes you feel comfortable. Again, I'll just take the actual numbers and reproduce them here so we could look at them in a little more detail. Again, we've just looked at the price index and its percentage change, and we know that there's a difference in the time patterns, and we want to discuss that. If I look at nominal and real GDP, again in red you can see that we have the recession years, and if I calculate the percentage change in real GDP, for example, between 73 and 74, I see that it's declined 0.5%. And similarly in 75 it declined another 0.2%. So we had recessions in this period, but if we go back and look at nominal GDP, it was increasing by 8% and 9% because of the increases in the price level. So again, nominal GDP is not a good reflection of what's actually happening in the real economy, and to do that we have to separate out the price influences, and that's what we do in real GDP. If we go down here and we look at the other recessions, 1980 and 1982, you can see this is kind of a happens once, happens again. This is called a double dip. I want to look at that. So we had a decline in real GDP of 0.24 and then 1.91%. While the nominal numbers that we're looking at actually showed a growth in the market value of GDP, and that's mostly because of the increase in prices. So now we have a pretty good idea anyway of the measurement of nominal GDP and real GDP, and how price indexes tie these things together, and how we use price indexes to measure inflation or the general increase in prices. You should be able to move back and forth through these simply. I think it's pretty easy, and understand the differences in these things. We know that real GDP is measured in constant dollars. That is, we take 1 year set of prices and value all the years in that one set of prices. Whereas nominal GDP is always measured in its current year. So the price profile is changing from year to year. So in this series, we've looked at GDP and its measurements. Now we have a basic understanding of nominal and real GDP, and we're going to begin to look at the macroeconomy in a little more detail. And the first thing we're going to look at is the banking sector, to understand this movement, as you recall from the circular flow, of savings into investments. And so the first thing we need to do to understand the financial markets then is how to read a balance sheet, and specifically a bank balance sheet. So we'll see this in the next lecture. Thank you.